Challenge activity 7.1.3. A software company is interested in improving customer satisfaction rate from the 60% currently claimed. The company sponsored a survey of 181 customers and found that 116 customers were satisfied. What is the test statistic? Up above, higher in the module, they reminded us that, or they told us that the test statistic is going to be p hat minus p naught. Remember, p hat is your sample proportion. P naught is that number you're testing. So in this case, it's 60% or 0.6. So p hat minus p naught divided by the square root of p naught times 1 minus p naught, all divided by n. So we're going to go ahead and put that into Excel. So we have the number of successes. Remember, that's our x, or the numerator when we calculate our proportion. So in this case, it's 116. That's right here, the 116 satisfied customers. We have the number of observations, n is 181. That's the number surveyed. We have p hat, which is the number of successes divided by, divided by our observations. We have p naught, and that's given to us as 0.6. So let's go ahead and calculate our z test statistic. So this is going to equal, we have p hat minus p naught divided by the square root of, we have p naught times 1 minus p naught. Sorry, I'm trying to be very careful with making sure I enter this correctly. Oops, let's do this here. Sorry, I'm really particular about parentheses. All right, so we have, let's double check this. We have p hat minus p naught divided by the square root of p naught times 1 minus p naught divided by the number of successes, that n. All right, let's click enter. That gives us 1.22. So let's go ahead and click that in, or type that in and check it. Challenge activity 7.1.3. A software company is interested in improving customer satisfaction rate from the 64% currently claimed. The company sponsored a survey of 298 customers and found that 204 customers were satisfied. So we need to find the test statistic z. So as a reminder from earlier in the module, z equals p hat, which is the sample proportion, minus p naught, which is this 0.64 that we're testing, divided by the square root of p naught times 1 minus p naught divided by n. Make sure that that's all under that square root. So let's go ahead and put some of our stuff into Excel here. So we have the number of successes. That's the number of people that are satisfied. That's 204. And we have the number of observation. That's our 298. We have p hat. Remember, that is the number of successes divided by n. P naught is given as 0.64. So let's go ahead and type in our z. So we have equals. On the top, we have p hat minus p naught divided by square root of p naught times 1 minus p naught. And what's nice is once you type this in, if you use it all as a formula like this, then you can reuse it for other problems. So close that parenthesis, divide. Oh, that was a mistake. Okay, hold on. Let me just retype that. P hat minus p naught divided by square root of p naught times 1 minus p naught divided by, oh, you know what, it was fine. Divided by n, close parenthesis. All right, so we get a 1.60. Let's go ahead and type that in here, 1.60. Let's double check, 1.60. Check, green check mark. Let's go to the next one. So an airline company is interested in improving customer satisfaction, similar problem, from the 59% currently claimed. The company sponsored a survey of 139 customers and found that 93 customers were satisfied. So we just need to replace some values in here, right? Because we're looking at the same thing, we just have different numbers. So basically, those are different and that's different, but we're not going to change our formulas. The number of successes here are 93 that were satisfied. The number of observations are the 139 that were surveyed, and our p hat is 0.59. So look, it already populated all that. So it's kind of, like I said, handy to leave it all there. Now we need to find our p-value. Now, we are going to be using the norm.s.dist. So we're going to say equals norm.s.dist, and we're going to open it up and we're going to put in our z value, and we're going to say, yes, it is cumulative. Now, I want to point something out here. I'm going to go ahead and hit enter to show you the answer. We get 0.97, but remember that we're looking to find the area to the right of that value under the curve. This area right here that's reported is to the left. Remember, the z distribution it returns the value, the area to the left. So we actually need to change this a little bit. Remember, the sum of all probabilities of 1. That is 1. That means that the area under the entire distribution is 1. So to find it on the right side of that z value, what we need to do is actually say 1 minus this value. And we're going to get 0.029. So let's go ahead and put these values in and see where we are right there. So our test statistic ended up being 1.90 once you start rounding it. Actually, let me double check the number. 1.90. And then the p-value is 0.029. And it says, does sufficient evidence exist that the customer satisfaction rate is higher than the claim by the company at a significance level of alpha equals 0.01? So remember, when p-value is less than alpha, we reject the null hypothesis. When p-value is greater than alpha, we do not reject it. So we would not say that there is evidence to exist to suggest that the rate is higher. So the answer is no. Let's check our answers. Nice little green check mark. A home improvement company is interested in improving customer satisfaction rate from 67% currently claimed. The company sponsored a survey of 291 customers and found that 241 were satisfied. So let's take a quick look. So let's clear out the numbers that need to change. So first we have our number of successes, 204. 291 from our survey. P hat is 0.67. So these have updated. Our z value we know, but let's double check something. Before we get into the p value, we need to actually read down here and see our hypothesis, because here it looks like they're talking about improving it. But one thing I noticed, it says, does sufficient evidence exist that the customer satisfaction rate is different than the claim by the company at a significance level of alpha equals 0.1? So in this case, that implies a two-tailed test. So remember, before we had that 1 minus, we're going to take that out. I'm sorry, let me go back a second. We're still going to leave that in, because now what we're trying to find is the area that's either greater than that z 1.12 or less than that net z equals to negative 1.12. So we're trying to actually double what we found here. So what we're going to say is 2 times, and then we're going to do that. So now we're saying 2 times 1 minus that. All right, so we should get 0.260. Again, we're looking at the curve, and we have the 2 lines, and we're looking for the areas to either side of it. So the test statistic is, I keep moving this over so I can actually see it. Z is 1.13 when it rounds. Our p-value is 0.260. And it says here, does sufficient evidence exist that the customer satisfaction rate is different? So the p-value is greater than alpha, which means we fail to reject. So the answer is no. It does not state that they're different, because we can't say that. All right, green check mark. That's how you do a customer satisfaction survey for challenge activity 7.1.3. If you have any questions about that or anything else, let me know.